point is we will talk about something called as typecasting. What is this concept of typecasting all about? Typecasting means conversion of one
Changing
type
data types.
of data to another. Fine. Conversion of one type of data to another, which means this. Let's see what is type casting is all about. Byte A is equal to 10. Is that valid variable?
Yes.
Yes.
So it's valid.
Short B is equal to A. Is this like the stuff is given me as valid or not?
Valid.
Valid. But what am I trying to store? I'm trying to store A into B or not?
Yes, sir.
Am I trying to store A into B? Let's take it like this first. If you are confused, let's take it like this. Byte A is equal to 10, byte B is equal to A. What will be the value of B?
10.
What will be the value of B?
10.
10. Correct?
Yes.
Okay. Let's run this. So you will get this 10. This minus 128 is the value of this X. Okay.
Yes, sir.
You're getting 10 as the value for B because B equals to what? B equals to A. So whatever is the value of A, we will get that into B, no? Now what will be the value of A? Now what will the value of B?
101.
101.
That line is clear? B
Yes,
equal
sir.
to A. Okay. Similarly, you can see that I can write something like short C equal to A. Now in the above case, I don't find any problem. Line 50 and 51. I don't have any problem. Byte type of variables are storing the value of each other. That's fine, right? But here, what is the type of
Yes.
C there?
Short.
Short. Short is trying to store which type of data?
Byte.
Byte type of data. So two different data types, right?
Yes.
So now see, C is, do I see any error there?
No.
No error, which means it is valid.
Yes, sir, it's valid.
I'm converting a byte variable into what type of variable?
Short.
Short. That is what typecasting is all about. Conversion of one type of data to another type. So is it converted and stored? Let's call it as C
Yes,
equals
sir.
to C equal to plus C. Right. So it will give me the value of C. After that, C equal to. So what is C equal to? 101.
1.
So can a byte be stored into short?
Yes, sir.
Yes. This is casting itself.
Yes, sir.
Casting, but the type of casting is implicit.
Implicit.
What is implicit typecasting? Implicit typecasting is also called as compiler casting. What is it called as?
Compiler.
Fine. Wherein we don't need to do anything. Compiler will automatically convert that byte into short. Now see another thing. What is the type of the variable?
Short, sir.
Short. Can byte store 15 or not? Byte can store 15 or not?
Yes, sir, it's possible.
Yes.
Let's say byte E equal to D. So when I'm writing byte E equal to D, do I see an error or it is valid?
Invalid, sir.
Error.
There is an error, right? I cannot say E equals to E. There is an error. Can't E store 15? E can store 15 or not?
You can store
Sir.
15, but
E can store
byte data type.
15. But because two different data types are there, what I have to do?
Convert.
Typecasting is required. Here also casting was required, but it compiler data casting. Here also casting is required. If I just write this line, it will give me an error. If I write this line as this, do I see any error?
No, sir.
No, sir.
And you see the value of E. E is storing 15.
Yes, sir.
Yes, sir. Explicit conversion.
This is called as Explicit,
Implicit conversion.
right? Which is also called as the developer cast, not case, cast it is. Fine. Now you might be thinking, line 56 implicit cast, line 63 explicit cast. Why is that? Right? And in some cases it is doing implicit cast, and in some cases it is asking us for providing a explicit cast. Why is there a discrimination, right? There's a discrimination here. Now let us understand why is that. Fine. Okay, let's go out of this topics and let's talk about very basic thing. Let's take two glasses, water glasses. This is one glass. Meeting controls keeps disturbing all the time. Let's say there is another one. Any difference in these two glasses?
So its size.
Yeah,
Size.
size is different.
Size.
Nice. Let's define some capacity. Let's say this glass can store 250 ml water, and this can store 500 ml. Okay.
Yes, sir.
Imagine both glasses are full up to here. Both are full. Fine. Let's say this 250 ml is full. Can I take this and fill it here?
No, sir. It's already full.
Here. If it is not full, this one 500 is not
Yes,
full.
sir.
Yes, sir.
Can I
Yes,
take
sir.
this and fill it here?
Yes, sir.
Yes, sir. It's possible, sir.
Yes. Okay, super. Do I lose anything? Like, will the water overflow?
No, no, sir.
No, right? That is case number one. This is full. We are trying to pour this in this, and this will just be half, right? Its capacity is more, so half. Nothing will be overflown. Now, next, understand same thing. Scenario number two. I'm doing a vice versa case. This is full, and I'm trying to pour this into this. Can I do that?
Overflow occurs.
First,
No,
tell me, can I
sir.
do it or not? Can I do it or not? Yes, I can do it.
Yes, sir.
But what will happen?
Overflow occurs.
There can be loss of this water, right?
Yes.
Overflow. So the compiler also tells us the same thing. If you wish to do it, do it. In the previous case, what compiler was doing was 250 ml into 500 ml. Is there any loss of data?
No.
No loss of data. So in the previous example, you see what compiler did for us. Byte was getting converted into what?
Short.
Byte B was getting converted into byte
Short.
A was getting converted into short C. What is the capacity of byte?
8 bit.
8 bits.
Bit.
Was stored in 16 bits.
16 bit.
Is
Bits.
there any loss of data?
No, sir.
No, sir.
No loss of data. So compiler says, oh, okay, you want to store a short variable. That means a lower value into a higher value. No problem. I will do it. I'll do it. It will say implicit. Because both belongs to the same category only, no? This is byte, which can store what?
Integer.
And this one,
Also integer.
short. This will also store pure
Integer.
integer. So it says both are fine. I'll implicitly convert it. You don't worry about it. Compiler says I will manage all that. In next case, what was happening was you were trying to store that 16 bits into how many?
8 bit.
8 bits. There is a chance that 16 bit is not full. In this case, there is a chance that the glass is full up to here. If it is full up to here, will you lose any data? Will you lose any data if you put this into this?
No.
No, right? This has this capacity up to here. It has the capacity. If it has only 100 ml, it is fine. It will fit in here, right? Yes or no?
Yes.
Yes, sir.
So that's what the compiler says. If you are sure that it is 100 ml, you give me the confirmation. I will try to pour it. I'll put it as per your command. It will do typecasting. Compiler does the typecasting. Compiler is doing conversion here, but it is asking you to convert it or not. Here, is it an explicit cast?
Yes, sir.
Yes,
So
sir.
here compiler is taking a confirmation. Give me the confirmation. This is like giving a confirmation. I understand that D is short. Convert that D into byte, even if I lose the data. Even if I lose the data,
True.
because D may contain what? 215 also, right? Can that 215
Yes,
be
sir.
stored in byte?
No, sir.
No, sir.
That's why it requires a confirmation from the user. If you lose the data, if you're okay with losing the data, then it is fine. You give me that. Else I will not. Fine. So in this case, there is no problem. It is half full and you're getting that data, complete data. So you're getting E as what? This E as 15. Are you getting E as 15?
Yes, sir.
Let's take the same example. Let us have a short. F is equal to 255. Fine. Or else let's say it is 128. And byte G is equal to F. First of all, it is not possible, right? Higher
Yes, sir.
value variable getting converted into lower one. So what has to be done? Explicitly, you have to say cascade, convert it into byte. Now, do you think like G will store G equals to what?
124.
G equals to what? F, right?
120. 128.
G equals to F. So what is the type of G? What is the type of G?
Byte. Byte.
Byte.
Byte. Can byte store 128?
No, sir.
No, sir. Not possible.
120.
That's the reason it is giving me an error. That's the reason if I don't write this, it gives me an error. You're trying to store a variable that may contain higher capacity value than the one you have, right? That's why it is asking me a confirmation. Did I give the confirmation there?
Yes,
By
sir.
writing this byte? Yes, I'm saying yes, even if the data is lost, no problem for me. You store it. Now, do you think byte can store 128? Value of G should be 128 is what we are expecting, right?
Yes.
Can byte store 128?
No, sir.
No, it cannot. Byte cannot store 128. What is the maximum value which can be stored in byte?
127.
127. Now let us run this and see what is the result. Now you see the result. It is showing me what?
Minus.
Minus 128. That's because it cannot store 128. Acha, let's say 255 is the value here. And now if you run this, you will see that it cannot store 255. What does it show?
-1.
-1 is what it is storing, is what it says. Fine. Now you might say, how does this happen? Right? How does this happen? I would say 256. How much I'm storing?
256.
256. You'll get 0. Are you getting 0?
Yes.
Now you might be thinking, why? How am I getting that result, right? How am I getting that 0? Is what I was expecting here. Expected result is
256.
256.
but I'm getting what?
0.
0.
Why is that? That's because can byte store 256?
No, sir.
To understand this, you have to get into the memory management. Where you should get into memory management. Like this, here we discussed something, right? We discussed something over here. You remember this?
Yeah.
Let us understand this once again. In the next example, probably you will get to know why am I getting that result and how I was able to tell you that I will get 0. Two blocks of memory I will design. Fine. Or else I'll not take this. I'll design it right from here. Row is added, columns are not added. So how do I define it? Can I have a table of more columns? Let's insert table. Yeah, columns, how many I want? 16. And rows, I just want 1. Fine. So this is the 16 block stuff here. Last block index will be how much? 15, right? Okay. Then 14, 13 likewise. I'll just write it here as 0. Okay. So what type of memory is this? What type of memory is this?
Short.
Short memory. So 0, 1, 2, 3, 4, 5, 6, 7. I'll just draw something over here to differentiate. Yeah, here it is 8 and this is 7, right? Just to differentiate. Now, let's have the same number system and everything. Up to this we have already drawn. It is up to this, up to 7, right? 2, 4, let's say this one as 1 first. Okay, 1, 2. 4. 8. Then this will be 16. (32) and 64. Let's move this 128 here. And what will be the next number here? 255, right? Sorry, 250.
56.
56. Fine. So this is at the 8th block, then so on. Okay, I'm least bothered about that. So now this is a short memory or not? This memory is short.
Yes, sir.
Just to view, I cannot, comes down. Fine. So if 128 I'm storing, if I'm storing 255 in short memory, all of this will be 1 or not? 8 ones I will have there. 255 I'm storing. And where will be the 0? The 250.
8th block.
Here it will be 0. And 128 plus 127 is how much?
255.
255.
Right? Super. So what happens if I convert that short into a byte? 255 if I take. So in 255, here I had taken an example of 255 there. You remember this? 255 I took. And this 255 became what? 1. Minus 1 in fact. It became 1, right? Minus 1. Yes or no? Is 255 becoming minus 1?
Yes, sir.
Okay, let's go to the memory and understand why it is becoming minus 1. Is this the memory stored in short?
Yes, sir.
Okay, now what you do is cut this off here. Cut this off here. Is it byte now? 8 blocks is byte.
Yes, sir.
Yes, sir.
Everything in byte is how much?
255.
Everything in byte is how much?
127.
See, What is here at 1?
Minus 127.
This is minus
So minus
128, right? If it
120.
is 1, it is minus, correct?
Just minus 120.
Yeah, this is
Yeah.
minus 128. And all of this are 1 means plus 127.
127.
So
Plus
plus 127 and minus 128 is how much?
minus 1.
Minus 1. Is it giving you that result?
Yes, sir.
Yes.
Yes, sir.
Yes.
If I take 256, what am I taking? 256.
56.
So if you look at this, the same diagram, 256, how will it be stored in memory? 256. Will this be 1? No. All of this will be what?
0.
0. There will be only 1 when I am storing 256. Where that it will be? At this
Here,
position, no? 256. So if I cut down this 256, when I'm writing 256 and I cut it down here, what remains?
0.
0. So for 256, I run it. What remained in byte?
0.
That's how I'm calculating. Got the calculation? How the data is lost?
Yes.
It is actually the memory which is cutting down. What's cutting down?
Memory.
Very cutting down.
So there is a chance when the memory is cut down, there is a chance of losing the data. That's why the compiler is telling you, give me the cache there. If you don't give the cache, there is a problem. Fine. So let's say 260. How will you store 260 in the memory? 256 plus
4.
4, right? So here there will be 1,
Yes, sir.
correct? So
Yes,
what
sir.
is this? 260, correct? If I cut down this, what remains?
4 only remains.
Only 1 at 4th position remains. So what is that?
4.
4, right? So let's write 260 and cut it down into byte and then get the result as 4.
4.
Do we get 4?
Yes, sir.
So is that the logic working there?
Yes, sir.
Yes, sir. Got it.
That's how you cut off the memory. That's how implicit typecasting and explicit typecasting is required. Why is it not asking you a typecasting in why it is doing implicit typecasting is if you are converting this memory byte into short, is there any chance of losing the data?
No, sir.
No, sir. No chance.
The data. You are adding the memory extra, right? Adding extra memory will not lose the data, but removing the memory will lose the data. Got that point?
Data. Yes.
So that's why whenever you are coming from a lower level variable to a higher one, then compiler understands and does the casting for you. If you are doing a higher level
High
variable is
into
coming to a
lower.
shorter one, the lower one, then compiler will ignore the casting and it will ask the user to perform the typecasting. Clear with this?
Yes, sir.
So which we call it as upward casting and downward casting. Upward means a short variable going above. That means byte going above. Here it was B was byte, right? A was byte. Let's comment this. A was byte and A is getting converted into what? A is getting converted into what?
The short.
Short. So byte is going up or coming down?
Going up.
Going up. So that is upward casting. Upward casting is always implicit. Upward typecasting is always
Implicit.
And here short is becoming byte. So is it going up or coming
Downward.
down?
Coming
Down,
down.
sir.
Downward casting is always
Explicit.
Implicit typecasting.
so because in downward casting there is always a chance of losing the data. That's why compiler needs a confirmation from the developer. So this is the concept of typecasting, conversion of data from one type to
Another.
another. I hope this concept is clear to you.
Yes, sir.
Yes, sir.
Okay, with this concept, we will understand one very important thing. I guarantee you that you have not learned that in your colleges, but you have used it. You have used it, but you have never focused on it in your colleges. Now you will come to know, oh, this is why we write that. Now, what is that? Acha. What I will do is I'll take some different type of variable. Float x is equal to 10.5, and I'll do a system.out.println x. If I remove this comment line, what will be the result of my code? If I remove the comment line, what will be the result of my code?
10.5.
Error, sir, error.
Error.
Garbage value.
Java will never give you a garbage value. That does not happen in Java. So either it gives you an error or gives you the value. So how many of you believe this is going to give us an
Error.
error? If I uncomment this error,
Yes.
Yes, sir. Error.
just raise hand whoever believes
Yes.
error. 3, 4, 5, 6, 7, 8. Okay. 7 believes the error. Why is that?
So float requires
Float requires last में F
First thing
रहेगा sir.
is error. Float needs this as F.
Float requires last में F
Right.
रहेगा.
Okay. So have you
Yes, sir.
ever
Now
thought
it's
of
okay.
this?
No.
Have you ever thought of this?
No, sir.
No sir.
See, this is valid 10.5. You never write it, but is it valid?
Yes sir.
Yes, sir.
Okay. Now, why do you use that F is my question. Why do you use this F?
No idea.
To show float value.
See, writing this float or writing this F is same.
We use F to distinguish between double and float.
Is this both giving the same result?
Yes, sir.
Both giving the same result. So writing this and this is same or not?
Same.
So what is this concept called as? In the previous example, I had written something
Explicit conversion.
Typecast.
explicit cast, right? This is
Yes, sir.
also explicit cast. Now, the question is, what are we casting, right? What is casting? Conversion of data type from one type to another, right?
Yes, sir. Yes.
So you see this. Do I need to write anything like F or D somewhere there here for this
sir.
double?
No,
right?
sir, no need.
Is it giving me the result 15.5?
Yes sir.
Yes, sir.
Yes.
Now what compiler reads all the decimal values as?
Double values.
Double. Is double higher than float or lower than float?
Higher than float.
Higher than float. So double is coming to float. Is it going downward or going upward?
Downward.
Going upward.
So whenever this 10.5 is considered as what by default?
Double.
Double.
Double. And you are storing it into what?
Float.
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 Needs the what? Needs what?
Typecast.
Going downward.
Typecasting.
Coming
Right?
down.
Downward typecasting is always explicit.
Explicit.
And either prefix it with F or suffix with float. Both are
Float.
same. Both are same. In both case, what are you doing?
Double
Explicit
to
casting.
float.
What are you converting from and to what? Explicit
Double to
cast.
float.
Double to float.
Float.
Why double to float? Because by default, all the decimal values are
Compiler.
read decimal as double.
double. So because in every programming, it is considered as double. That's why you write that F. What that F signifies now?
Float.
Typecast.
Typecasting.
Yeah.
It is explicit casting.
Explicit
So
cast.
this is also fine. Makes no difference. Either this or this makes no difference at all. Both are the syntax of casting, but this one is more popular. And people will just tell you, For float, you add f. What they tell you for float, write f. You understand? Okay. For float, f needs to be written. Why?
For type it.
That's because by default decimals are double. You are downgrading it. Because you are downgrading, you are reducing the memory. That's why you have to write that f and agree that you are considering it as a float value. Fine. So you use this before
Yes.
also, right?
Yes, sir.
Now you got to know what for it is used.
Yes, sir.